Okay, let's talk about 3D printing. And basically, the way you can make my life easy is to get the MakerBot desktop software. The link is on Canvas, and it's PC or Mac compatible. You can log in as me, just like you did with the augmented reality software. And what this will allow you to do is upload your completed model to the library, my library, and I can see it a little more easily. And you should tell the software that the device you're using is the Replicator Z18. And the big thing for me when you prepare your print is save using your last name. That would make my life significantly easier. So setting up the model is pretty straightforward once you have the software. You just choose File, Add, and you add your model to the prepare zone. And then there's a number of ways that you can modify it. Let me show you what that looks like. This is the MakerBot desktop software interface, and it's pretty straightforward. If you click the eyeball button, you can kind of see a preview of the model, and in fact they show you basically the entire volume that we have to print in. The device we have is a Z18. 18 means 18 inches tall. When you insert your model, you just go to File, Add, and then you browse for that OBJ file. And here's one right here. And that model can be moved around, for example, just by clicking and dragging on it. If you long click on the move button, you can move it at an exact amount. Everything is in metric for some reason or another. Centering it is generally a good idea. You can also rotate it, and again, you can double click on this thing and rotate it even more. And you can scale it. This thing, the printer can print up to 18 inches high, and it will warn you if you're printing too big. My advice is go smaller, just a few inches across. 75 millimeters would be ideal, because otherwise it's going to take forever. Okay, that would certainly make my life a lot easier, because we don't have a week to print every single person's model. And do not forget, please, to upload to the library. That will save it to my account. The other thing that's kind of cool, there is a store where you can download things to print, and over in the Life Sciences building I see keychains and iPhone covers being printed all the time, which is pretty funny. Anyway, and there's a preview button which will allow you to see what it's going to look like. Basically a view of your model that will show exactly kind of where the printer is going to be moving, creating lines, because there is internal structure to this model. The black lines indicate the travel moves that the print head is going to be making, and that's really the main source of errors that we see. So if you see any weird geometry or lines shooting off into outer space, that is a problem, and you'll obviously want to let me know if you notice that. The big thing is it tells you about how long it's going to take to print, 2 hours and 8 minutes. That's often off by an hour or two. But at least we want to keep these things under 4 or 5 hours, because otherwise we will never get them all printed. Anyway, if you drag down, you can see the layers that the system creates, and it basically has an internal structure that it generates to help the thing stand up, and otherwise it prints these layers individually. So I don't see any lines shooting off into outer space, so we're good here. And you can click export and create a file that can be printed from directly. You won't even need the MakerBot software. You can just put it on a USB. But for us, uploading it to the library is the way to go. So back on preparing the model, you'll want to rotate it, put it in the middle, and put it on the build plate. And the 3D printer, it's basically a device which extrudes out a thin layer of melty plastic and builds up one layer after the other. So you do end up with lines on the model. We can change settings to be smoother. You can also sand or use chemicals to smooth out the finish. We can go as big as 18 inches, but like I mentioned, just keeping it down to a few inches is ideal, or about 75 millimeters, since the device only accepts metric. And you can rotate objects in 90-degree increments or in single individual increments using that rotate command. You will want it to lay flat onto the build plate. And you can rotate the model upside down or sideways if you need to get a flat edge lying on the ground. It doesn't have to be flat, but it makes cleaning up the model later easier. There are a number of print settings. For us, most of the time we're just going to use standard printing. Low quality does print faster, but we've had some problems at that speed, and high quality just takes forever. And I would not use any of the advanced options unless you're in a tweaky kind of mood. And like I mentioned, the print preview allows you to see the individual moves of the print head, which can help us preview any potential slicing errors. And when it's ready to print, you don't have to hit print. You can just exit out of the export menu and upload it to the library. What the MakerBot software will sometimes do, by the way, is it likes to put in supports. This is a model that somebody created last year, and the supports were added by the software to help the model stand up straight. And you chip those off later on. There are a number of other problems that you might see, including holes in the model or those strange black lines heading off into outer space. So here is a model where you're seeing strange areas of gray where it doesn't look like a model. It doesn't look like anything really. And often when you rotate the model, it will look kind of blank. And that's often a problem. This is what's called a normal problem. Those can be fixed. There is software out there called NetFab. Again, if you find that you're doing a lot of 3D printing for whatever, your studio work, by all means, you'll want to look at that software. It will highlight in red problem spots in your 3D models. And this is probably more of a problem with models coming straight out of SketchUp. There's also another problem, another software out there that can fix your problems, just your 3D printing problems, I'm afraid. And that is from Microsoft. There's a free online website. You do have to have a Hotmail address to log into it. But you upload the model, and actually I've had very good success repairing the models using this software. You can also use 3ds Max if you happen to know it. We have it on the desktops in the Art Center. Anyway, finally, you don't have to export it. If you do, it saves it as a .thing file. Yes, that's what it's called, a .thing. You can also save the file. Just hit save, not export. And that will save it as a MakerBot file. That will allow me to open it up again and make any changes if need be, particularly if the model is too big or too small. I can change the size of it. The thing file can be printed directly, so you can actually plug that into a MakerBot using a USB drive. And you don't need any software at all, which is kind of nice if the computer is tied up. What I would recommend in terms of scheduling, first of all, get the model posted first so that I can just take one quick peek at it. But if everything is fine, you'll want to track down the lab monitors, the print lab monitors. There probably will be someone around who can get your print started. Nice thing about the 3D printer is that once the model has started up, you can just walk away. You don't have to stick around and watch it. Unlike the laser cutter where somebody has to be in there so that we don't accidentally burn down the building. Anyway, there is also a 3D printer, same model and make as ours, on the second floor of the Life Sciences building, kind of all the way in the back. That is open and available. You can walk in and use it any time of day or night. It's first come, first serve. So while we don't use it a lot, last year when our 3D printer went down for a while, we did use that printer, and they don't seem to mind. So take advantage. Anyway, when you are on the software, just in case the lab monitor doesn't know how to use it, you just call up the MakerBot software, log in, open up your model, and then all you have to do is hit print. It's really that easy. The only problem is that our MakerBot is a little cranky, so sometimes things don't come out. The bigger the print, the longer it takes. That's why I strongly recommend you do the print preview first, because even a medium-sized print can take 24 hours, and we don't want to chew up time on the machine. There are a few other requirements for this project. A simple rendered view, which actually you probably have already done for producing your virtual reality view. And that can be fine. You can use simple materials or transparent materials if that's what your object is supposed to look like. You can just use the outside sun only. And that works fine for virtual reality viewing. However, some of you have ideas of more complicated materials, bumpy things, and that sort of stuff. If so, there is a bonus lecture on advanced use of materials that I posted on Canvas, and you're welcome to take a look at that. And you probably remember from Electronic Media 2 or 1 or whenever that there are all sorts of ways that you can manipulate materials and make them bumpy and make them transparent or make them have cutouts. So just it kind of goes over that information. The other thing is a meta-analysis, standing back from your project, and you've done now 5 different views of this same project. What does each of these views show best? And think about each one. Which one helps you in the design process? That's really what we want to know is, are you going to use any of these techniques in your design process in the future to make better designs? Also, were any of the views surprising, including the 3D print? Obviously, it's not a full-size print, but is there anything that you saw or felt in that final drawing or final VR, AR view or final print that tells you more about your design than you were able to see just through the other media? For the presentation board, obviously there will be a physical model and a physical board. Probably 18 by 24 is fine. You can actually choose whatever size you want. So 12 by 36 is also fine if you want to save money printing. And please do me a favor, upload the Revit project and the file PDF. And there's a number of things that we've talked about, the artist statement, the hand sketch, model iterations, and screenshots of the AR and VR views. It would be great to have a photo of the final model and a single rendered perspective. Obviously, people in that rendered perspective would be really great. Finally, the meta-analysis. What does each drawing type or media type tell you or not tell you about your project? So for homework, this assignment actually isn't really due for a couple of weeks, just due to the lag time in getting the 3D prints back. So, but I really would like you to kind of finish it up because we're going to be moving on. The big thing for next class, get your OBJ file into the MakerBot software. You also want to render your model. And then there are a couple of lectures that you can listen to, including lecture 4A, the bonus lecture on materials, and a little bit about lighting. And then when you're done with all this, time to move on to lecture number 5 on our laser cutter project. Anyway, and that's basically it for this week.